You're kneeling next to a pottery kiln. It's roughly 5000 BC, somewhere in the Balkans, in what's now Serbia. The fire's been burning for hours. Hot enough to bake clay, hard enough to hold water and survive a drop. And sitting at the base of that fire, half buried in ash, is a chunk of blue-green rock that's been sitting there since yesterday. Somebody grabbed it because it makes decent pigment, decent body paint. This morning, when they pull it out to check on it, it's not blue-green rock anymore. It's got strange, reddish, shiny beads stuck to the surface, glinting in a way rock has never glinted before. This is the story of how humans discovered copper. Not pennies, not wiring, not the green rooftop everyone assumes is oxidized paint and is actually oxidized metal. We're talking about the very first time a human being pulled metal out of stone and didn't even fully understand what they'd just done. Because here's the thing nobody tells you. Copper doesn't start with mining. It doesn't start with furnaces or smiths or trade routes. It starts with someone picking up a rock that was already metal, sitting right there on the ground, and hitting it with another rock. Let's start with native copper. In a handful of places on Earth, Anatolia, the Great Lakes region of North America, parts of the Middle East, copper occurs naturally in a pure metallic form. No smelting required. No chemistry. No fire. No furnace. Just a reddish, oddly heavy rock that, if you hit it, doesn't shatter like flint. It bends. It flattens. It behaves completely differently from every other stone in your toolkit. The oldest known worked copper object, a small pendant found at a site called Çayönü Tepesi in what's now Turkey, is roughly 9,000 years old. Cold hammered. Not melted. Not poured. Just beaten into shape the same way you'd shape a piece of leather. Around the same time, on the completely opposite side of the planet, communities near the Great Lakes in North America were doing the exact same thing with their own native copper deposits, hammering it into knives, fish hooks, and beads for thousands of years without ever building a furnace. Two groups of people, no contact with each other, arriving independently at the same discovery. This rock isn't like the other rocks, but hammered copper is still, technically, just advanced rock hitting. It's a variation on stone tool technology, not a new one. The actual revolution, the moment that changes everything, is smelting. Pulling metal out of rock that isn't metal to begin with. And that requires an accident. Here's where it gets interesting. Malachite, that blue-green rock from the kiln, is a copper carbonate. Chemically speaking, it's copper bound up with oxygen and carbon, locked inside a mineral that looks nothing like metal. But heat that rock hot enough, in the presence of charcoal, and something strange happens. The carbon in the charcoal starts stealing the oxygen away from the copper. What's left behind, once the chemistry finishes, is pure metallic copper. Little beads of it, sometimes no bigger than a grain of rice, sweating out of the rock like it's melting from the inside. Nobody in 5000 BC understood oxidation states or reduction reactions. What they understood was, I put a blue-green rock near the fire, and now there's shiny metal where the rock used to be. And once you've seen that happen once, you don't forget it. Archaeologists have found exactly this kind of evidence at a site called Belovode in Serbia, dating to around 5000 BC, roughly 7,000 years ago. Furnace slag, the leftover waste from smelting, sitting right there in the archaeological layer. Not far away is Rudna Glava, one of the oldest known copper mines on Earth, where people were digging shafts directly into a hillside to chase copper ore underground. This wasn't a one-off accident anymore. This was a repeatable process, a piece of technology, passed down and refined. Now, here's the question that should be sitting in the back of your mind. Does the oldest evidence we've found mean that's when it actually started? Or does it just mean that's the oldest evidence that happened to survive? Because early smelting probably happened accidentally, in ordinary cooking fires and pottery kilns, over and over, for who knows how long, before anyone thought to do it on purpose. A stray piece of malachite used as pigment, A kiln that ran a little hotter than usual. A shiny bead nobody bothered to record because it looked like garbage. Most of that leaves no trace. The rare version that leaves slag behind, in a spot an archaeologist happens to dig thousands of years later, is the exception, not the rule. So the honest answer is, we've found the moment we can prove. We almost certainly haven't found the moment it actually began. What we do know is that this wasn't a one-time invention that spread outward from a single genius. It happened again and again, in places with zero contact with each other, independently. Smelting shows up in the Middle East, in the Iberian Peninsula, and on a completely different continental clock, in the Andes of South America, and in early China, each region arriving at essentially the same trick through the same basic accident. Hot rock, charcoal, patience. Let's talk about medicine. Because copper's story isn't only about tools and weapons. Ancient Egyptian physicians were using copper therapeutically over 30,000 years ago. The Edwin Smith Papyrus, one of the oldest surgical texts in the world, recommends copper for sterilizing wounds and treating infection. Egyptians stored drinking water in copper vessels, specifically because water kept in copper stayed cleaner longer. They didn't know why. They just knew people who drank from the copper jar got sick less often than people who didn't. It turns out they were onto something real. Copper ions are genuinely toxic to a wide range of bacteria and viruses, a property modern researchers call the oligodynamic effect. Hospitals today are experimenting with copper touch surfaces, door handles, bed rails, precisely because copper kills pathogens on contact. An ancient Egyptian physician and a modern infection control researcher are 4,000 years apart, making the exact same observation for the exact same reason. There's also the status angle, and it matters more than people give it credit for. Copper is rare. It's difficult to produce, and it looks unmistakably different from anything else available in the Neolithic world. That combination makes it valuable in a way flint never was. Suddenly, who controls the copper? Who knows how to smelt it? And who gets buried with it becomes a marker of status. Archaeologists find copper objects concentrated in specific graves, not spread evenly across a community, which tells us something uncomfortable. Metallurgy may be one of the very first technologies to create real, visible inequality between people. Which brings us to a concrete case, one of the best preserved windows we have into this world. In 1991, hikers in the Alps found a body frozen in glacial ice, a man who died around 3300 BC. Researchers named him Ötzi. Among his belongings was a copper axe, and when scientists analyzed the blade, they found it was alloyed with arsenic, a technique that makes copper harder and holds an edge longer. That's not the work of someone stumbling onto a lucky kiln accident. That's the output of an established craft tradition, with known ore sources, known techniques, and a trade network moving material across the Alps. By 3300 BC, in other words, copper wasn't a discovery anymore. It was an industry. Now here's the uncomfortable part of the story. Smelting copper isn't cheap, and it never was. It takes a genuinely enormous amount of charcoal to reach smelting temperatures, which means it takes a genuinely enormous amount of wood. Entire hillsides around early mining sites like Rudna Glava were stripped bare to feed the furnaces. One of the first documented cases of humans reshaping their own landscape in pursuit of a technology. Mining itself was brutal, physical, often fatal work. And as copper extraction scaled up across the ancient world, it increasingly relied on forced and enslaved labor. Roman-era copper mines at Rio Tinto in Spain worked for centuries by enslaved and condemned laborers, left behind a river so saturated with mineral runoff that it still runs a startling blood-red color today. Thousands of years later, what started as a shiny bead in a Balkan kiln fire ends several thousand years down the line as an extractive industry with a body count. A Neolithic farmer noticing a strange glint in the ash and a Roman mine overseer working prisoners to death underground both handled the same metal. Almost nothing else about them is the same. So when did ancient humans discover copper? The honest answer? Again, is that we don't know exactly. And we probably never will. The physical evidence takes us back roughly 9,000 years with real confidence. And the smelting breakthrough, at least 7,000. But the underlying moment? The accident of noticing that one particular rock behaves differently when it gets hot? Could have happened.
Unrecorded.
Any number of times before anyone left a trace we could find. What's clear is that the behavior is old enough and useful enough that it kept getting reinvented independently across the planet, in places that never spoke to each other, that never traded with each other, that in some cases never even knew the other existed. Different people,
Different continents.
the same fire, the same rock, the same realization. Next time you plug in a charger, or turn a key in a lock, or flip a light switch and feel the click of the copper contacts closing somewhere inside the wall, you're touching a direct descendant of that first shiny bead sweating out of a piece of ash-covered rock. The wires changed. The tools changed. The scale changed almost beyond recognition. But somewhere at the bottom of all of it is still the same fire.
The same rock.
And someone who reached into the ashes without knowing what they'd find. You're still holding the ember,